Factoring quadratic trinomials when the value of a is greater than 1. Now remember, a quadratic trinomial is in the form of ax squared plus bx plus c is equal to 0. When a is greater than 1, one method we can use is a variation of the AC method. To find the solutions of the quadratic equation when a is greater than 1, satisfy the following steps. And yes, I want to indicate something, that this means greater than, and this symbol the other way means less than. Okay. Step 1, make sure the quadratic equation is equal to 0. And if it's not equal to 0, move everything to the other side so it can be equal to 0. Step 2, take the a term and multiply it to the c term. Here's an example of how that will look down below. You're going to take the value of a, and you're going to multiply it to c. You're literally going to move it and multiply it to c, giving you the term of ac. So now we have x squared plus bx plus ac is equal to 0. This looks very familiar to quadratic equations when a is equal to 1. Step 3, factor the x squared into two parentheses, an x in the left, an x in the right. Step number 4, find two numbers that multiply to AC and they have to add to B. Take your R and S. Suppose R and S multiplies to AC, and when you add R and S, it equals to B. Then you can place those factors in each of the parentheses, as we see right here for step 4 continued. Now remember how you multiply the a to the c? The c term is the constant of the quadratic trinomial. Math has to be a balance. You multiplied the value of a to the constant. So when you multiply something with an equation, you then have to balance it out by doing the opposite of that operation, which is to divide. Remember how we multiplied a to c? Well, we will have to divide the value of a from each constant. If the division does not result in a whole number, place your denominator in front of the x variable for that linear factor. So let's follow the steps. We're going to divide r and s by the value of a, because those are our constants. Now, we result in a polynomial in the form as follows. Now, here's an example. R divided by a cannot be simplified. Thus, place the a in front of the x for that factor. We couldn't divide this for a whole number, so we took that a and we placed it in front of the x of that factor. That's why we have ax plus r. Then we can say that s divided by a can be simplified to a whole number. Thus, let t equal to s over a. That's why for this one, there is no number in front of that x. Both pieces are equal to 0. Use the zero product property to find the solutions to x. Now, maybe that didn't make too much sense. Let's actually do a couple of examples to see how well we can understand, how comfortable we are to adapt into this. So we have 4 examples in this video, and we're going to answer all 4. Example 1 says find the solutions to the quadratic equation 2x squared plus 7x plus 6 is equal to 0. Now, as we can see, it's already equal to 0, so we're happy. To solve this, look at the first term. This is different. There is a 2 in front of your x squared. The value of a is 2. What we're going to do is we're going to utilize the AC method. You're going to take this 2 and you're going to move it over and multiply it to the constant of 6. So when we write that, it's going to be x squared plus 7x plus, well, that's going to be 2 times 6. And that's equal to 0. 2 times 6, that is 12. We'll put that in yellow. And let's bring down everything else in white. So we have our x squared plus 7x plus 12 equals to 0. Now we can factor this as a regular quadratic equation, a regular quadratic trinomial. So the factors of x squared is x and x here, and then x there. And we want to find two numbers that multiplies to positive 12, and when we add them, we get positive 7. So multiply to 12. Two numbers that multiply to 12, 1 and 12, 2 and 6, 3 and 4. Everything is positive, so all the numbers should be positive. 1 plus 12 is 13. That's not the same thing as 7. Doesn't work. 2 plus 6 is 8. It is not 7 in the middle. That does not work. 3 plus 4 is 7. This does work. There is a 7 in the middle. So it's x plus 3 times x plus 4. And remember, this is equal to 0. But once again, remember in the beginning how we multiplied 2 to our constant of 6 to get 12. We must keep the equation balanced. Because we multiplied by 2 earlier to our constant, we now then have to divide 2 from every constant. Divide the 3 by 2. Divide the 4 by 2. And let's see what we can get when we divide. 3 divided by 2 is a decimal. It is not a whole number. That is 1.5. Because this cannot divide evenly, you're just going to take this number 2 and stick it in front of the x right there. So I'm going to go up here. That's going to be 2x plus 3. Let's make some more space. Let's erase that and rewrite that again. That's going to be 2x plus 3. Now look here. 4 divided by 2 is 2. That results in a whole number. So now we're going to have x plus 2. Once again, 4 divided by 2 is 2. That is a whole number. There is nothing to put in front of the x. And we can set that equal to 0 and solve for x. Now we're going to use the zero product property to solve for x. So we have 2x plus 3 equals to 0. And we have x plus 2 equals to 0. Subtract 3 from both sides. The 3's cancel each other out. We have 2x equals to negative 3. Divide both sides by 2 to get x by itself. The 2's cancel each other out. Simplify rather. And our first solution to this equation is negative 3/2. The second solution is going to be found when we subtract 2 from both sides. The 2 simplify each other out. We have x is equal to negative 2. And there you go. Those are our two solutions. Should put more space in these PowerPoints. Okay. Next example. As we can see, this quadratic trinomial is not equal to 0. I'm going to have to move that 5 to the other side by adding 5 to both sides of my equation. Negative 5 plus 5 is 0. On the left side, we have 6x squared minus 17x plus 5, and that's equal to 0. Once again, the value of a is greater than 1. It is 6. We're going to use the AC method once again by moving this 6 and multiplying it to the 5. So when we do that, we now have x squared minus 17x, and that's going to be plus, it's that 6 that we just moved over, times 5. And that is equal to 0. Six times 5 is 30. Bring down everything else. X squared minus 17x plus 30. We want to find two numbers that multiplies to positive 30, but then it also adds to negative 17. So multiply to 30. We're going to have 1 and 30, 2 and 15, 3 and 10, 6 and 5. That's why I want you guys to practice your times tables so you can be comfortable with finding numbers that multiplies to bigger numbers. So let's first factor our x's. Set it equal to 0. An x here and an x there. This middle number is negative. Because the middle number is negative, but the product is positive, that means both numbers have to be negative. Negative times a negative is a positive. Negative plus a negative is a negative. So every term in this case is negative. And we're adding to see what we get. Negative 1 plus negative 30 is negative 31. Negative 2 plus negative 15 is negative 17. Negative 3 plus negative 10 is negative 13. Negative 6 plus negative 5 is negative 11. Do we see which pair works? Yes, we do. Negative 2 plus negative 15. So minus 2 minus 15. Now remember how we multiplied our 6 to the constant of 5? We now have to do the opposite by dividing 6 to both constants. And now this is where the tricky part comes, because you have to be comfortable with reducing your fractions. 2 and 6 are both even numbers. And when you go to your calculator, you must make sure you can reduce your fraction. 2 divided by 6. Hit second. Rather than hit second, hit math. Make sure you go to fraction, which is the first one. That gives us 1/3. So now we have, in our parentheses, I didn't mean to do that. X minus 1/3 times x minus, do the same thing. 15 divided by 6, 2.5. Go to math, make it a fraction. That's 5/2. X minus 5/2 equals to 0. And because we still have fractions, we can then take the numbers in our denominators after we reduce and stick it in front of each of those x's. Three x minus 1, you put the 3 in front, times 2x minus 5 equals to 0. All right, so now we can use the zero product property. Set both pieces equal to 0 and solve for x. Let's do the first one. 3x minus 1 equals to 0. We can just add 1 to both sides. 3x equals to positive 1. Divide both sides by 3. Those two simplify each other out. X equals 1/3. Then you can do the same thing for the other one. 2x minus 5 equals to 0. You want to solve for x by adding 5 to both sides. 2x equals to 5. Divide both sides by 2 to get x by itself. X equals to 5/2. And those are our two solutions to this quadratic equation, 1/3 and 5/2. So this one was a longer process than the other one, but it's still the same type of procedure whenever the value in front of the term is greater than 1. Let's do 2 more examples to see if we can have this down packed. And I'm using different variables, but the variables that I use makes no difference. It's the process that stays the same. So for example 3, the quadratic trinomial is already equal to 0, so that's great. We're now just going to multiply this value of 10 to the last term. So using the AC method again, we have w squared minus 27w, and 5 times 10, that's going to be 50. Let's rewrite that, make it look more like a 27. 27w plus 50 equals to 0. Once again, we multiplied the 10 with the 5. Now we want to factor. We want to find two numbers that multiplies to 50 and adds to 27. W there, multiply to 50 and adds to negative 27. So numbers that multiply to 50, we know we have 1 and 50, 25 and 2, 10 and 5. All those numbers multiply to 50. Now you must add to negative 27. Because we're multiplying to a positive number, but adding to a negative number, both terms must be negative. Negative times a negative is a positive. And when you add two negative numbers together, the number is still negative. So make all these negative. And we're adding between each of these terms. Negative 1 plus negative 50 is negative 51. That doesn't work. Negative 25 plus negative 2 is negative 27. That one works. So we're going to put our negative 25 here, and we're going to put our negative 2 here. Now remember the same process from before. Once we're down to this step, because we multiplied the 10 with the 5, divide both numbers by that number we multiplied. Divide both of them by 10. And then use your calculator app or use your calculator to reduce the function to reduce the fractions. 25 divided by 2, that's rather, excuse me, 25 divided by 10 is 2.5. You can go to math, convert that into a fraction. Oh, there's an add on this calculator. Wow, thank you. That's 5/2. So we have, in parentheses, W minus 5/2 times W minus, let's reduce 2 over 10. Math, reduce that. We have 1/5. W minus 1/5 equals to 0. So if you notice from before, the solutions will just be the opposite side, the opposite signs of each of the numbers that are there in the factored form. But once again, we're going to continue using the AC method to simplify. So because we have denominators, put those denominators in front of the variable. So that's going to be now 2W minus 5 times 5W minus 1. And that's equal to 0. Use the zero product property. 2W minus 5 equals to 0. And then the other one is going to be 5W minus 1 equals to 0. When you solve for W, W in this case will equal to 5/2. And W will equal to 1/5. I want you guys to solve for W as we did in the previous examples. So our solutions is going to be 1/5 and 5/2. Now we can move on to the last one. Just take a minute to absorb it all in to see if it makes sense. Look at the process that we utilized every time we want to factor using the AC method in this fashion. Okay, the last one says 2v squared minus v plus 12 equals to 13. Remember, we must have the quadratic equation equal to 0. So what we're going to do is subtract both sides by 13 to have the right side equal to 0. 13 minus 13, that's gone. That is 0. Now, bring down everything else. 2v squared minus, I'm going to put a 1 in front of that v. 1v. And 12 minus 13 is negative 1. And that equals to 0. Now, once again, we can use our AC method by multiplying the A term of 2 with the C term of negative 1. So when we do that, we're going to go over to the left side. That's going to be v squared minus 1v, 2 times negative 1, that's negative 2, equals to 0. And now let's factor. V here, V there. We want to find two numbers that multiplies to negative 2. And when they add to the negative 1 that's in front of there. Multiply to negative 2, and they add to negative 1. The only numbers that multiplies to negative 2 will involve 2 and 1. But which one will be negative? Well, whenever you're multiplying to get a negative, one number is positive, the other one is negative. Because the middle term is negative, that means the bigger of the two numbers will be negative. So 2 will be negative, and the 1 will remain positive. Negative 2 plus 1 is negative 1. And negative 1 is our middle term. So we can have a positive 1 because the 1 is positive, and the 2 is negative. And remember, that is equal to 0. Change the color on my pen. Now remember how we multiplied our 2 to our 1, right? We now have to divide the 2 from every term. Divide the 2 from the first constant. Divide the 2 from the second constant. 1 divided by 2 does not work. We know that 1 divided by 2 is 0.5. So because we can't divide that, we're going to stick our 2 in front of the variable to give us 2v plus 1. In the other parentheses, 2 divided by 2, this here is equal to 1. So there's no need to do the same thing. We receive a whole number when we divide. V minus 1, and that is equal to 0. And then last but not least, we can use our zero product property. I'm going to go over here to the right side. Zoom out just a little bit for the zero product property. So let me erase that actually. We just can go over here. So that's 2v plus 1 equals 0. And then we have v minus 1 equals to 0. And I want you guys to verify the solutions for me. For this one, v equals to negative 1/2. And when you solve for v here, v equals to positive 1. And that are the solutions to our quadratic equation. Negative 1/2, comma, positive 1. So that is it for factoring quadratic trinomials when the value of a is greater than 1. We can use the AC method. There are also ways that you can do this as well, such as factor by grouping and trial and error. But this is the best way, at least I think this is the best way for finding the solutions to a quadratic equation when a is bigger than 1. So I want you to use the 4 examples that you see on the PowerPoint. I want you guys to try questions 9, 10, 11, and 12 on your worksheet/homework. All right, guys, I'll catch you in the next one. Take care.